Hi, and welcome to this session. You have probably heard me speaking here at Techorama about topics like C#, like .NET, like TypeScript, Angular, Blazor, and so on. But today, I will cover something completely different. I will talk about Go. I will talk about my journey towards Go and why I, as a passionate .NET and C# developer, really have fallen in love with this language and this ecosystem. I already told you that I will do a lot of demos, so if you want to have the demo code, just take a picture, or maybe you already have taken a picture from this slide. All the samples are available on GitHub. I will also record this session and I will make it available on my YouTube channel. So, what can you expect? We will do a short introduction about the basic philosophy, the basic idea behind Go. I will do a lot of comparison between C# and Go. Why is Go different? What are the core principles of this language? Then I want to get you excited. I want to show you a lot of code samples where you can see how Go looks like, how it feels to write code in Go, and how the whole ecosystem works. And finally, at the end, I have some more elaborate samples, a little bit in the direction of Web API and so on. So I would like to show you what the road ahead could be. If you want to, for instance, build a microservice with Go, how is it different and how would something like that work? Good. Let's start with the introduction part. I will keep it short. We will focus mostly in this session on live coding. So, why? Why am I interested? What raised my interest when I took a look at Go? First, I do a lot of work with Docker. I use Docker every single day, and Docker is written in Go. That's interesting. Go has become the 13th most popular developer technology in the last year's Stack Overflow surveys. And in this survey, Go is in front of languages like Swift, like Kotlin, or Dart. Go has become the 9th most loved dev tech in the Stack Overflow survey, most loved developer technology in front of C#. That's a pretty bold statement. Go compiles to native code. That means I don't have dependencies. You know, if I develop C# or TypeScript, I always have to deal with these dozens and dozens of DLLs in my publishing folder. If I do a self-contained deployment, or if I do some TypeScript work, I always have to deal with this node modules folder. With Go, everything is much simpler. You have your application, you compile it, and out you get a single file in native code with no dependencies. Just copy it, run it, works. That raised my interest. And finally, I didn't mention that, WebAssembly support. I'm a big fan of WebAssembly. I love to deploy my non-JavaScript code also in the browser. Go allows me that. All these things, they raised my interest. Because of these things, I took a closer look at Go. Now, what have I learned? First, I was a little bit surprised when I took a look at the language Go. And I had to understand the basic philosophy of Go. First, Go wants to keep your code simple, much simpler than C#. C# has over 100 keywords. Go has 25. That's a lot. That also means that the language of Go is somewhat limited compared to C#, but this is by design. The core idea of Go is if you write code, please keep in mind that your code will be more often read than written. So the Go code shouldn't be too clever. It shouldn't be overly smart. And I would like to cite one statement that I copied from the Go documentation about memory management. Let me read it to you. If you must read the rest of the document, a lengthy document describing how memory management in Go works, to understand the behavior of your program, you are being too clever. Don't be clever. That's one of the most important statements in Go. Keep your code simple, okay? Keep your code consistent. The first time I wrote a Go program, I had no idea what I was doing. I accidentally created an exported function. And then Go told me I had to write the documentation on top of this function. I didn't want to do that, so I was looking for a kind of linter config file or something like this, and I found out there is none. Every Go program that you write is formatted in the same way. There is a Go formatter, and either you accept it or you don't write Go code. Every Go code looks the same. There is no configuration file in terms of code formatting, in terms of warnings and things like that. Every Go code looks the same. Is that just because it's too young? It's younger than C#? Well, Go is already pretty mature. It came out in 2009. The version 2 is just in the design phase. We are still in version 1, but still we are in version 1.13, and it's not just because Go is young. These basic philosophy ideas are our core idea of the language Go, and with that it is kind of different compared to C#. Now let's take a closer look at the language. The idea of Go is that with every extension of the language team consciously decides whether it's worth it. Every language addition also adds complexity. And if something is possible, maybe with 2 or 3 lines of code, the Go language designer will not introduce some syntactic sugar to put it into 1 line of code. Because, hey, write 3 lines of codes and write the obvious code. That's one of the most important ideas here. There is a very open discussion project, and experience and learning are valued from the language team. The language development is relatively slow. It's not that fast like in JavaScript, so that's kind of relaxing if you're using Go. And finally, Go has a very strong commitment to compatibility. Your code will run in the same major version no matter what. The source code, not the binary code, okay? And we have 10 years the same major version. So we have backwards compatibility for a long time. This is somewhat different if you compare that to C# or JavaScript. Now, of course, that comes with limitations. When I first took a look at Go, I was looking for classes. There are no classes. I was looking for generics. There are no generics. I was looking for try-catch. There is no try-catch. There are no binary-only packages. Everything is always compiled from source. Do you want to publish your library to your suppliers or partners? You have to publish your source code. I'm very sorry. See, the ++ is a statement, not an expression. So you cannot write if ++i. It's simply not possible. And when I took a look at all these things, my head was somehow exploding, because from C# I was used to all these things, and I was so near to just go away and thought, okay, that's not my language. But then I took a closer look and I understood that it's absolutely possible to write useful software even with these limitations. So what? Go is about avoiding overly smart code. The code should be easy to read and easy to maintain. Go only improves when it really makes sense. The language is only extended when we have a real significant limitation that we cannot work around. Then the Go language is extended. No syntactic sugar. Don't improve too fast, because we need to be compatible. And Go is optimized for the server side. So I do a lot of microservice and web API development, and this is where this language really shines. And because Docker is also written in Go, Go is perfect in a world of containers. And I will show you in the demos in a minute. So for me, Go, when I switched from C# and JavaScript, I still use these languages, but when I switched to also use Go, it was a kind of detox. See, not so fast, not so many language enhancement, not so many inline ifs and ++ and encapsulated statements and expression-bodied members, all these things that came into C# in the last years, these things simply don't exist in Go. But Go has a few very interesting concepts that I would like to show you, which make really a difference when writing microservices and web APIs. So that's an introduction to Go. From now on, we will do demos. First, let's start with a very simple example. I am here in Visual Studio Code. Visual Studio Code is a great way of writing Go code, and I will put my demo script here to the side, and inside my live folder, let's add a new file. Let's call it main.go, and we will write some code here, and good. That's it. So the first thing that I would like to show you is how the module system works. There is no NuGet, there is no NPM. The module system in Go is GitHub. Or let's say your source code management system. If you would like to reference a package from somebody else, you are referencing the source code management system. In my case, GitHub. So let's initialize a Go module. Let's do that. I will run this command. It's the go mod init command. And this go mod init command, I'm in the wrong folder, I'm sorry. Now let's rerun this command. If I run this command again, now we have a mod file and it tells me the name of my module and it tells me the version number of the language that I'm currently using. That's good. Let's put this to the side. And then we can add in our main.go file a little bit of code. And let me show you this code, what it does. It's really simple. We are focusing now on the modules. You see you have an import statement similar to using. You are just using a bunch of modules, and these modules are now loaded from GitHub. The source code is loaded, and Go compiles the entire application from source code, which it gets from GitHub. And then I can just write some code. Here you see the main function. I will not go into the details. I think you can understand what this does. Understand this one. This was interesting for me. You know, I learned programming many, many years ago using Pascal, and now I see this declare and assign statement. This declares a variable and immediately assigns a value. And in this case, I'm creating an ASCII renderer from a tool called Figlet. It's an ASCII art generator, and then I render a message, hello world, from another component. That's all, and then I use the format.print in order to print that. So it's a kind of hello world on steroids. So let me run this guy, go run dot, and the result will be that it understood that I'm importing a package, goes to GitHub, downloads the package in GitHub. Now I have a dependency here in my module file, and the application worked. You see, it prints hello world. So modules are similar to what you might be used to from Node or from C#, but the big difference is that you don't have a separate package format. You're just referencing the source code in GitHub. The source code will be stored in a folder in my user directory. I could now show you the folder, but it doesn't pay off. There we have the cloned version of this GitHub repository, and it also uses the version tags in GitHub or your source code management system to give your versions of the library, certain version tags. Good. That's the first one. You can cross-compile. Now let me clean up a little bit here. Here we have our main.go. What we can do, if I open my commands again, I can build an executable. That's simple. It's go build. If we do that, should be finished immediately. You see, we get a single executable with no dependencies at all. If you compile to Linux, you can run it directly on top of the kernel. No dependencies, no runtime. Does Go have a runtime? Of course it has a runtime, but it's baked into the executable. You can just take it and run it on if you want Windows 7. So let's give it a try. I can say modules.exe and it tells me hello world. Looks pretty nice. Very good. Now, can we cross-compile? Yes, we can. Let me start a new command shell and now set two environment variables. Go architecture. Let's do that. Whoops. Go operating system, Linux, and then do the go build again. This time, I'm still on Windows, but this time I was creating on Windows a Linux executable. It's still a single file, no dependencies. We can run it directly on top of the Linux kernel, and we will do that in a second. Now let's run this Linux file, just run a bash, and then we just say modules, and you see, this works perfectly fine. So from a single Go code, we can reference our packages and build a Windows version, a Linux version, and many other versions too. Good. Good. How does that look like if you want to run this stuff in a Docker file, in a Docker container? Because I told you, Go really shines when it comes to microservices, web APIs, and things like that. So it's kind of natural today to put your microservices in a Docker container. Let's create a Docker container from our really nice Hello World application. So let's create a Docker file. Oops, wrong folder. Here we are. Here, let's create a Docker file. Here it is. And I have created snippet for that. You see this Docker file is built. Oops, I have to scroll up a little bit. Nice, good. This Docker file is built on the Docker image Golang, which contains all the necessary things in order to compile Go languages. And here I'm just calling Go build inside a Docker file. And then I'm running it on top of an Alpine Linux. I'm just copying the file that I create inside the Docker file onto a plain Alpine Linux. Nothing installed there. And at the end, I'm running my application, which should print hello world. Let's give it a try. So, you saw the Docker file. Let's Docker build this guy. Docker build. You see, it's running in the container. It gets the sources from GitHub. It compiles everything. And at the end, we should see a working Docker image. Yes, here it is. Let's take a look. If we take, first, let's run it. So you see that it really runs. Now, you see, I'm running the Docker container based on the image that I just created. It's Alpine Linux with a Docker executable on top. Now, let's check how large this image is. Docker image hello go, and we will see in a second that it's currently 9.9 megabytes. That's a hello world application. Of course, you will have larger images, but this is your code that is added to this application. That's pretty awesome. When I saw this, I thought about, oh, how large are my Docker images when I'm using C# with ASP.NET Core? Not 9.9 megabytes, a little bit larger. But we can make it even better. I would not recommend doing that in real life, but you can do that. You can say, hey, forget Alpine. Let's do a from scratch. Let's sit directly on top of the Linux kernel inside of our Docker container. Of course, we cannot do that one, and we cannot do that one. Absolutely no problem, but that's it. Now, let's rerun the build. Now, I'm really sitting directly in the Docker container on top of the Linux kernel. No additional operating system inside here. Again, the build runs. Give it a second. Should be done in a few more seconds. Yep, looks good. So now, run this guy. It works. From scratch, no Alpine, no Ubuntu, nothing like that. And then take a look at the size of the image. That's pretty nice. 1.88 megabytes. Now, the session title is Go and why .NET developers should care. That's efficiency. And if you have such small Docker images, okay, granted, you will not make it from scratch. You typically want something like Alpine Linux in your Docker container, I understand that. But still, a bunch of megabytes for a basic workload, that's fine. Of course, you add additional code, I understand that, but that gives a kind of baseline. That made really a difference for me as a .NET Core developer. .NET Core is pretty good, has become pretty good, but still has a far way to go to reach such dimensions. Good. Let me quickly check what I already did. Yes, looks good. I did that sample. And yeah, this one. Now, what about WebAssembly? Let me move to the right folder. I created another example for you. It's in this folder here. And do you know what the queen's problem is? The 8 queens problem? How many solutions are if you place 8 queens on a chessboard so that no queen can beat the other queen? That's the queen's problem, okay? So what I did is I have written a simple algorithm. It's here. You see, it's just a very simple algorithm. You can take a look. It's just an implementation in Go of the n queens problem. And I've also written some unit tests. Yes, Go has a built-in unit testing framework. But the interesting thing is you don't have things like asserts and so on, because the Go language designer said, hey, you have an if statement. Why not write an if statement inside of your unit tests? Keep things simple. So let's give it a try and let's run this guy. So let's go into the queens and say go test, and let's see whether everything works. Please ignore these red squigglies. They are just because my file layout is as it is. Pass, that's good. So the tests work. So let's give it a try and let's run this 8 queens problem as we did it before on the command line. So here it is in the WASM folder. Go run, and it should tell us, here it is, that we have 92 solutions, and as an example, it shows us 2 chessboards, how they look like if we place 8 queens. This is just an application. This is just an you don't see the, you see it again. Good. This is just an application. Let me show it to you. Here it is, that prints results to standard out. That's all. Don't worry about the rest of the Go code. We have enough time to go into the small details. Now we are focusing on something else, because now I would like to run exactly this business logic code in my web browser using WebAssembly. I already showed you running Go code on Windows. I already showed you running Go code on Linux inside of Docker containers, and now I want to go into the browser. Good. Let's try that. I have built a nice little Docker file for that does nothing else than, as you can see it here, to a Go build, but this time I'm setting the Go operating system to JavaScript and the Go architecture to WASM. That's the difference here. So we are not generating a single executable for Windows or Linux. In this case, I'm just generating an executable for the browser. And then I'm copying this stuff again into a plain web server, Nginx, and configure it as a static file server. That's all. That is what this Docker file is all about. So let's try this Docker file. Oops, here we are. We did that one, and good. We don't need that one. This is what I want to run. Good. Let's run the Docker build. Oh, not the Go build. Here, the Docker build. I was in the wrong line. This executes our Docker file. It builds my application. The build is also running in the Docker container. And at the end, it generates the Nginx container. Everything's fine. Now let's run this guy. It's just a background web server. And then let's open a web browser and go to F12. And you see, it really worked. Just to prove the point, let's rerun it. You see, it really worked. We see exactly the same output that you have seen before on standard out, but now in the browser's console. And if we take a look at the network, then you see we still have a single file, a single executable. But this time we have an executable which is WebAssembly and runs inside the browser. Now you might ask yourself, can I somehow communicate with JavaScript and call JavaScript from Go, or call Go from JavaScript? Can I somehow manipulate the DOM and do something like that to, I don't know, to integrate that in my nice little Angular Vue or React application? The answer to all these questions is yes. It's a plain WebAssembly file, and there are enough packages that work really nice if you want to interop between JavaScript and Go. I don't have the time today to show you that live, but please believe me and take a look at my GitHub repo. You will find larger examples there where you can, maybe it's a good starting point for you. So summarize. You compile into a single executable. You can cross-compile from Linux to Windows, from Windows to Linux, into WebAssembly, and so on. You have no dependencies at all. Copy a single executable and it runs. No dozens or hundreds of executables. No zip files which get extracted when first run, like it is in .NET Core 3, for instance, where you end up again with dozens of DLLs somewhere in the file system. A single executable on all platforms. That really raised my attention when I first looked at Go. Good. Now, you might now, or I hope now, you are interested in seeing more about this Go language itself. And now let's spend a little bit of time exploring the Go language. How does Go feel if you really build applications? I have a bunch of snippets here, and the first thing that I would like to show you is that one. Let's quickly dissect this code. I zoom in a little bit. The first one is the package name. Okay, we understand that. Then you can import a bunch of stuff. It's like the using statement in C#, and then it becomes interesting. I told you Go doesn't have classes. There are no classes in Go. Therefore, you define so-called structs. Structs have nothing to do with value types and reference types like in C#. It's much simpler. There is no kind of reference type or value type in Go. If you create a variable, doesn't matter if you new it up or whatever, Go decides itself whether it uses the stack or the heap. You cannot influence that. Go will take a look at your code. It will perform a so-called escape analysis. Do you use this variable outside of this method? If yes, it will probably land on the heap. If not, it will probably land on the stack. But as a developer, you simply don't care. It's not like a struct in C#. That is important. So here we have a point struct, x float and y float. Very simple. Here we have a rect struct, which is using the point struct from up here. I think you can guess the details from the context. And then I have a circle with a center and a radius. Very simple. Now down here, I new up some of these types. I create a point, I create a rectangle, I create a circle, and at the end I'm printing out some stuff on standard out. Pretty simple, right? Let's try it. It works perfectly fine. Go, run, and it should print some results. Very simple. So first takeaway, no classes, but structs, no reference types or value types. Everything is automatically. Do you know whether point or rect or circle, whether these variables are created on the stack or the heap? No, and you shouldn't. You simply shouldn't care. Don't be smart. Let's go figure out the correct way to do it. Next one. Now let's change the point structure a little bit. What I want to show you here is that Go has a very nice concept of adding so-called tags to structure members. And one of the tags that you can add is the JSON tag. And this JSON tag, I think you get it from the context, supports marshalling into JSON out of the box. It's very simple. You can immediately put that with tags onto your structs. And of course, that is importable, and that is important when you create web APIs, for instance. Let's give this a try. We can use this guy by saying, I would like to print this one, save it. You see, there is a package which is called JSON, JSON.marshalP, and this will give us the JSON representation as a string, okay? So let's give it a try, whether it works. Okay, works. You see, here we have JSON. But there is another thing important when it comes to this example, because the marshal function returns not only a byte array, which becomes a string, a byte array where JSON is in it, it also returns an error. Yes, you see correctly, Go can return multiple values from a single function. That is very important because the error handling in Go is based on the idea that the last return value is the error code. If a function returns nil as the error, everything is fine. If a function returns an object, which is just any arbitrary object, this is considered to be an error, and then you can do some interesting stuff with this error. No exceptions like in C#. No try-catch, like in C#. The core idea is to have the error handling right where the error appears. It should never happen that you throw an error here, and then you go up and up and up and up the call stack, and somewhere up there, maybe somebody will care for this error. If you take a look at the code down there, you have no idea whether this error is handled or not. The idea of Go is put the error handling near the code where the error might have happened. If you want to ignore the error, absolutely no problem. You can use this underscore operator, and that tells Go, I'm not interested in the error. Okay? Very important stuff. Do you have something like exception handling where maybe something happens which is really, really critical, and it should lead to some critical exception handling and terminate the process? Yes, that's possible in Go. It's called panicking, and you can take a look at the documentation. I only have 60 minutes, so I will not cover panicking in Go here, but that's really an exception. The typical error handling is done like that. Next one. Let's add some functions. How can I add functions to structures? This is how we can add the function with to the type rect. This is the syntax here. So you define the type on the left-hand side and then the function. Of course, you have a result type. I think it should be pretty obvious how these functions work. Okay? That's easy. But we have something interesting down here. Whoops, sorry. That's better. Take a look at that one. Here, I'm adding a function to a reference to rect. And that means I can write to the instance where I'm hanging on as a function. Get the idea? The function here does get a reference, does get an instance of the rectangle. It's an instance that is probably copied, but I cannot write to it. Here I have a reference to the rectangle and I can really write to it. I can manipulate it. That's the whole idea. But don't worry, even that you have pointers, it's not back in the days of C and C++, so you don't have this strange pointer arithmetics and you don't have a void star that you can typecast to anything, and you don't need to write this arrow indicator. You can just use the dot operator even if you have a reference, a pointer to an object. So again, keep it simple. You just indicate whether you want to have a reference where you can write to, or whether you want to have a maybe copy where you cannot write to. Good. Looks good. So let's save this guy and use these functions. Function call, here it is. This is how you call the function, enlarge for instance, and in this case I'm calling the function that is changing the rectangle. I'm just enlarging the rectangle. The enlarge function got the reference of the rectangle and therefore it can change its members. Get the idea? I think so. Good. Let's give it a try. Let's do a go run. And it should compile correctly, and the rectangle's area is 400, and if you take a closer look at my code, that's the correct result. So this is how you define functions. Next one. Interfaces are super important when it comes to Go. You can define interfaces, and you do not, just like in TypeScript, add the interface to the struct definition. We don't have classes, therefore I cannot add it to classes. But what you do is you have so-called duck typing. If it walks like a duck, if it acts like a duck, we call it a duck. Structural subtyping is the name in TypeScript, what we are talking about here. So in this line here, or in this interface, we are just saying every type, every struct that contains, that offers a function called area that returns a float 64 value is considered compatible with the interface shape. You don't need to explicitly add the interface to the type. That means somebody can implement a type, somebody else can implement a structure, and if both look like ducks and walk like ducks, you can create an interface, duck if you want, and they immediately become ducks, although the implementers of the structures have no idea about the concept of a duck. Get the idea? That's duck typing. Let's call it structural subtyping. Okay? This is how interfaces work in Go. And in my case, I have the area function, and you see the area function is implemented by circle, it's implemented by rectangle, and yeah, I think that's it. So let's use this interface. Here, interface use, this is it. So you see, in this case, I'm creating an array of shapes. Shape is just an interface. Yes, you can create an interface array, of course. And here we add a rectangle and a circle, and that's possible because both offer the function area. If we would do a mistake here, I can go here and, for instance, remove this guy. Then we get an error because circle now no longer walks like a duck, so we cannot consider it a duck, therefore it doesn't work anymore. It's no longer a shape. Okay, let's undo that. We will need that later on. Good. Let's give it a try. Works. Perfectly fine. Next one. Okay, I'm on the wrong position, sorry. What about inheritance? this one. There is no inheritance. You cannot inherit. Not like classes in C#. You cannot say I have an animal base class and derive a type dog, for instance. It's not possible. But what you can do is you can aggregate. What you can do is you can say I have a colored circle, and this colored circle aggregates a circle and adds a color of type int, for instance. Get the idea? The interesting thing is that you can directly access the members of circle from the colored circle because I don't give it a name here. Okay? Let me show you what I mean here. Let's use the embedded struct. I have to move that one up for my demo. There it is. The colored circle embeds a circle. Can you remember it? Colored circle was a circle plus color. And therefore, because the circle is embedded into colored circle, it also knows how to calculate its area. Therefore, it walks like a duck, it acts like a duck, it is a shape, and we can add it to the shape collection. So it feels a little bit like inheritance, but it isn't inheritance. It's aggregation. That's important. And if we want to access the members, that's absolutely no problem. We can, for instance, say here, cc dot, and you see, of course we have get color, but we can immediately access the members of circle, although it is aggregated. We don't need to write colored circle dot area. That's an important one. So with this aggregation stuff, you can really reach similar things as with C# inheritance. Okay, and here you see that we also have kind of reflection. We can ask at runtime whether the instance is a colored shape, whether the instance is a colored circle. In this case, I'm asking whether it's compatible to an interface. I created an interface up there, which I called colored, and therefore I can conditionally print the color of the thing if it has a color. Okay, something like pattern matching in C# or is or as operator. This is how it looks like. We have some other interesting stuff here going on. Let me show you the for loop. This is a very interesting version of the for loop. You can range over an enumerable, in this case an array, but you will not just get the item like with the for each loop in C#, but you get the item and you get the index. How often have you dreamed of getting the index from the for each loop in C#? In Go you have it. Okay? If is also interesting. You see, the reflection, if you want here, returns two things. It returns the typecasted instance, and it returns a second indicator whether the typecast was successful or not. And in a single if statement, we can do such a declare and assign statement and at the same time add the condition. So if execute something, was it successful in a single line? That is pretty awesome, and you use this statement very often in Go. Please excuse that I cannot show you all the details of Go syntax, but I think you get the idea, right? Good. Last but not least, let me see. I think I have a last one. Do I have a last one? Embed structured used? No, I don't have a last one. This sample is done. So what do you remember from this sample? You remember from this sample, we don't have classes. We only have structs. No value types, no reference types. Aggregation instead of inheritance. Structural subtyping. Duck typing, quack, 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 walks like a duck, acts like a duck. Okay, then it's an interface. And we have some pretty interesting control flow statements like the for range loop and the if statement and so on. Good. Fair? Good. Next one. Let's take a look at pointers. Go supports pointers. And I have come up with a small application here. And let's quickly take a look at a few lines of code just to give you an idea. This, of course, is an integer value. This is how you get a reference to this integer value. Let's call it a pointer. You can dereference a pointer using star, just like C or C++, for instance. You can, as you can see it here, directly assign the value the pointer points to using the dereferencing syntax. You can create a function that receives a reference to something, a pointer to integer in that case, and so we can write a value to the pointer, to the memory where the pointer points to. I think you get the idea. You can get also from more complex things the address by using the ampersand operator. And again, I already told you that you can just use dot to dereference something where you have a pointer to. You don't need to always think about, do I have a reference or do I have a value, and one time you use dot and one time you use the arrow syntax. No, you always use dot. And Go will figure out whether you have a reference or whether you have a copy. Get the idea? No pointer arithmetic. Don't worry, you will not destroy something, okay? Next one. Oops. Error handling. I showed you a little bit of error handling, but I would like to go into more details here. This is a very, very trivial example for showing how to do error handling. You see, I created a diff function, and this diff function does not only return a result, but it also returns an error indicator. And you see, if something went wrong, I knew up an error object, and an error object is just another struct, and you can program with it. You can have embedded errors, which you can unwrap later on, all the things that you are used to with exceptions. But there is no special base class like exception. There is no throw statement. You just return an error indicator as the last element of your function. If everything is okay, you return nil. Now, how do you handle such an error? Oops, I didn't want to do that. Error handling. This is how you typically would call the diff function. You get the result and the error, and then you just check whether error is nil. If something bad happened, handle the error. If everything is okay, you can go on. Get the idea? No try catch, only panicking for extreme cases, not for the regular exception case. The idea, and this is what you should take away here, is to keep your code simple. Always have the error handling near the place where the error happened. That's the philosophy here. Good. Next one. Now we come to a real rock star in Go. And many people's interest becomes raised when we see the feature that I would like to now demo to you, so-called Go routines. Please take a look at this function. It's trivial. It just says hello world with a little bit of parameter. But now take a look at these two lines here. Say hello, it's just a call inside the same, we call it Go routine. Conceptually, a Go routine is similar to a task in C#, but only a little bit similar. There are really significant differences between a Go routine and a task. Each Go routine has its own stack, but the stack in Go with Go routines can grow and shrink. Therefore, you can have a lot of these Go routines. From a programmer's perspective, if you don't want to go in all the details of Go routines, just currently think of like a task in C#, okay? And with the Go keyword, we are triggering a new Go routine, like task.run. Many C# developers in the room, I guess, so task.run. This is what we do here. And then I'm just sleeping for 10 milliseconds, and I hope that the second Go routine will also have enough time to print its statement. Don't worry, we will take a look at synchronization in a second. So let's give it a try. Go run this guy, and it will say, hello from direct call, hello from Go routine. Pretty simple. Now let's take a look at something that is a little bit more interesting. So we are here. Let me move this thing up here. These two functions, they just sleep a little bit and then they return a value, but they return the value in a very new way, in a very Go-specific way. Go accepts a channel as an input. Channel is a very important concept in Go. Channel is like a kind of pipe where a Go routine can communicate with another Go routine. You can pass a channel into a Go routine, and the Go routine can use this channel to send you data back. In my case, the getValueAsync method receives a channel which is called result, and the caller of getValueAsync can pass in a kind of data pipeline, and when the getValueAsync has a result like this, it can use this channel to send back the data. We do not need shared memory. That's the important thing here. The caller on the second one is also very similar, but in this case we are just using a kind of indicator. I'm done. We don't have a return type here. So in this case I'm just sending true. I'm done. Now let's see how a caller would use this stuff. Let's do it like that. Exactly, that's good. Please remember the getValueAsync function. It received a channel of integer. And this is how a caller calls this Go routine. It just says, make a channel, create this pipeline, and then it passes the pipeline, oh, this is the pipeline, it passes the pipeline to the function. Later on, the function will use this pipeline to send the result back. And here you see this operator. This indicates wait until a value is available in this pipeline. Know what I mean? No shared memory, but strong typed pipelines with which one Go routine can communicate with the other Go routine. No locking, nor semaphores, nothing like this, just channels. And the Boolean channel is even simpler. If you just want to wait until the method is done and you are not interested in the value, you can just use this operator and say wait here until it's done. It's a kind of a wait statement, but it's not like in C# that a Go routine can only send one result, like with a wait. With a wait, you can only get one result. But with Go, you have a channel and you can say you can send many of these integers, for instance, or customers or whatever you have. It's a kind of C#8 async enumerable, but only a kind of. But I think you get the idea. The important thing is no semaphores, support for many Go routines very efficiently, and communication in a type-safe manner. Good? Good. Let me check where we are. We had that one, we had channels. Yes, next one. You will like this one, I hope. The select statement, it's not a select statement like in C#, understands channels in a very specific way. In this case, please take a look at the code. We have a getValueAsync, and then we are casing on the result. If we have a result, print the result. But then I'm using a different channel, a channel from the time package, which will send me a value back after the specified amount of milliseconds. And the case statement will decide, okay, which channel was sending data, and then it enters the correct case way. Get what I mean? So in this case, I'm getting the value in an async way, and if I get a result, everything is fine. But if 5 milliseconds are elapsed before I get the result, I print timeout. You get the idea? So the select statement can be used to react on messages from different channels. It's very common to have an endless loop forever, and then just have a select statement in the middle. And one of the case statements just say, okay, if I receive a channel on the, I don't know, done channel, for instance, if I receive a message from the done channel, I execute and say return or break or something like this. With this, you can wait for multiple Go routines and coordinate data coming in, flowing in through different pipelines and react accordingly using the select statement. C# has nothing like this. I can't come up with any kind of way that C# could do something like this. Finally, These channels are built into many of the standard functions that Go provides. For instance, you can initialize a so-called ticker, just one example, time.ticker, and this ticker, you see that one, is nothing than a channel. It has a member which is called C, and this is a channel that you can listen on, and the ticker will send you values through this channel as long as it ticks. The important thing here is that you can also for range over a channel. So it's a kind of for each loop over an asynchronous method that will block automatically if no value is currently available. Get it? But we run this in a background Go routine, and after 500 milliseconds, we simply call the ticker to stop, and then we get no longer any kind of messages. Get the idea? So programming with pipelines and channels is a very important concept inside of Go. It's built into the language. In C#, there is something similar. I think it's called a data pipeline framework. It's somewhere in the .NET framework, but it's not part of the C# language. It's somehow part of the framework, and therefore you cannot do many of the things that you can do in Go. So what is the takeaway of this example here? Async programming is one of the big strengths of Go. And this is obviously something that you often need when you build some back-end microservices with non-trivial workloads, for instance, accessing a database, running multiple database queries, doing async processing, and so on. Go is very strong in this area. Good. Another point where Go is really strong is C Interop. Of course, a platform like Docker, Kubernetes, Terraform, all these applications have been written with Go. They need to interact somehow with the kernel, directly with the kernel, and not everything is available in Go. So Go has to have a really strong integration with external applications, especially written in C, C++, Fortran, or similar applications. And I've created a small example that should show you how this C Interop works. I have implemented again my queens problem. Can you remember 8 queens on a chessboard? How many possible combinations of 8 queens are on a chessboard where no queen can beat the other one? And I've implemented this example in C. I will not go into the C code. It's really, really simple. Nothing special here. The point is, in Go, it's super simple to interop with this C program. All you have to do is you have to import a pseudo package C. If the Go compiler sees import C, it understands that your application does not only consist of Go code, but it also consists of C code and C++ code and Fortran code or whatever code you have inside of your folder or subfolders. And what it will do, it will call the appropriate compiler and compile it in the context of your Go module. So in my case, by compiling my Go app, I implicitly also compile my C application into an object file, and again I'm linking it directly into my Go application. No DLL, nothing like this, single executable, no dependencies, statically linked, including C code. That is pretty strong when it comes to low-level interop stuff, maybe in an IoT scenario where you have to talk to some low-level drivers, where you have some C drivers or C++ drivers. You just compile it into a single executable, and this is what you ship to your IoT device. If you think of the small Docker containers that I showed you before, that enables a bunch of interesting scenarios when it comes to IoT and Go. Why having a 60 megabyte Docker container on your IoT device if you can do it with 5 megabytes? So in this case, pretty simple. I am calling this function. I'm just calculating the number of solutions to keep it really simple and easy to use. And let's take a look at the code. I would like to draw your attention on the fact that we can call the C method with its name. We just say c.name of the method in the header file. We can also call standard functions because you can hash include standard libraries in C and also your own header files in C. So calling a C routine is really trivial, and you have all the necessary tools there you need in order to successfully call into your C code. Okay? So if you need to allocate some memory and have some pointers and have the structs marshal to C structs in order to communicate with your code, this is a strength of Go. This is where Go is really good at. So let's give this a try. I have not installed the GCC compiler on my machine, so again I will use Docker to compile this application. Let me show you how I do that. I go into the oops, this is the wrong one. I go into the C Interop folder here, and I have prepared, where is it, my commands, here it is. And here I'm just running the Go compiler inside of the Golang Docker image, and they have in their standard Docker image GCC installed, so it's easier for me to build it there. Let's do that. Here, let's run this one. It's just compiling my application. Will take only a few seconds, and here you see the result. Oh, I called it modules. That doesn't really make sense, but yeah, okay, that's fine. This one is the executable. It's not a CDLL, and then we DLL into something, we get a single executable, and the C code is baked into this executable, and now we can run this guy. Of course, I compiled it for Linux, so I have to use the bash for that, no problem. And I hope, yes, it works perfectly fine. We found 92 solutions. That's a correct solution for the 8 queens problem. And we see hello world because in my Go code, I also demonstrate the calling of the standard C function put string, put s. Okay? So C interop is a very important thing, and if you think of building microservices in IoT scenarios, I think this is particularly interesting, and again raised my interest in Go because many of my customers are now thinking of using IoT scenarios, of using lightweight containers on their production machines or production facilities, and Go has really its strength there. It's machine code, and therefore it's also very fast. Good. C interop. We are nearly at the end. Web API. How does a web API look like? I've prepared a web API for you. Let's take that one, and I have a snippet for that. Come on, give it to me. Here. A very, very simple web API created for you. It's really trivial, and we will take a look at a more detailed web API. But to make one thing very clear, this web API is not how you typically implement microservices in Go. It is just there to show you the concept of how Go web API development works. Of course, you have dozens and dozens and dozens of very interesting frameworks for building, for solving solutions for more elaborate scenarios. Do you want to build a really powerful microservice solution? Well, definitely you can, but probably not in a trivial way like I do it here. But again, we want to take a look at the basics, and maybe you have to use your imagination of what could be possible with all the packages that are out there. How does a very simple web API work? Number one, we generate, in this case, our structs. I'm just sending back a response in JSON, and therefore I'm using the JSON tag of my struct that will run my JSON marshalling, returning the response from my web API. Next one, I'm setting up a router. There are many routers, and you can easily have a very interesting discussion with Go programmers which router you want to have. I'm using one that is frequently used. It's called here the Gorilla Mux router. This is the router that I set up, and it works pretty simple. You just specify the URL, yes, parameters are possible and all this stuff, and then you specify a method, you see the method down there, that should be called when this route is activated. Very basic and simple router, nothing special. And then you just start here, you start the web server. Very similar to C#. It has a web server built in. You don't need an IIS or any other heavyweight web server. You just listen and serve based on the HTTP package, and an HTTP server comes up, and the router will care for routing your HTTP request to your functions. In the functions, you can write arbitrary Go code. You can access the query parameters, you can access the request body, whatever you want to do, and at the end, you are just In this case, you see it here, I'm encoding my response using the JSON marshaller. So I'm just setting up my structure here, and then I'm giving it to the JSON marshaller, and because of the tags, it knows how to translate that into JSON. So JSON support is really, really good. Also support for protobuf is also very good. gRPC, very good support for that. So whenever it comes to Web API, you have a huge community out there building lightweight Web APIs, lightweight microservices based on the Go platform. Let's give this a try. Let's move to the correct folder here. Hello. Oh, I'm already here. We are in live. Go run dot. Okay, allowing access through the firewall. It listens on port 8080, and it should listen on the greet endpoint. Let's try that. Localhost 8080 greet. And oh, I'm still running my Docker container on the port 8080. I'm very sorry. Docker ps -a. That was from the previous demo. So let's kill this guy. Docker rm f for e something like this, and run it again. Good. And let's try it again. Yes, hello world. And if I say question mark with answer equals 1, I will also get the answer to everything, of course. So it works perfectly fine. In my sample folder, I have a more complex, more complete sample in order if you want to look more closely into what you can do. So if you would like to dive deeper, just go into this Web API folder, and there I have implemented a little bit more interesting Web API that supports a real CRUD operation, adding lunch orders and getting them and filtering them and things like that. So if you want to have a more detailed sample, we only have 60 minutes, so I can't go through this sample with you, but you will find your way through this code with the basic knowledge that I gave you. And if I take a look at the clock, we are pretty good in time. So what is the conclusion? Why did I want to show you what I showed you? I have a site here from Joel Spolsky, and he says productivity is best improved by reducing complexity. And I think that's really the point. The reason why I am really looking into Go and why I made Go my third important language in my toolkit besides C#, JavaScript or TypeScript for web development, now I'm using Go regularly because the language is simple, and that is a kind of coding detox. Not every week having to update everything because every day a new framework or language feature appears. That's really relaxing. Very long-term compatibility. Simple language. The code cannot be as complex as some C# code might be. That's a very important thing. A lot of super interesting functionalities for microservices. Think of the channels. Think of the ability to work with pointers. Think of Interop. For IoT scenarios. These are the things that made me interested in Go, and this is the knowledge that I wanted to share with you in order to also raise your interest. Maybe Go is also interesting for your next project, and if it is, I would love to hear about your journey in Go. Can send me a tweet or contact me via my LinkedIn page, or review this session on my YouTube channel. I will publish it there, I guess, in the next few days, and maybe you can watch it again and try to replay the samples, and with that start your journey towards Go. I hope it was an interesting hour. I hope you got some new ideas and you opened new perspective for implementing microservices. I want to say thank you for coming, and I think it's time to enjoy lunch. Thank you.